Gravity glitch, forgotten force. We live our entire lives in its embrace, a silent, invisible master that dictates the rules of our existence. From the gentle arc of a thrown ball to the colossal dance of galaxies across billions of light years, its dominion seems absolute. We call it gravity. It is the force that clumps gas into stars, that holds planets in their orbits, and that keeps our feet planted firmly on the ground. It's so fundamental, so constant, that we almost forget it's there. We've built our understanding of the cosmos on the bedrock of its reliability. Isaac Newton gave us the first elegant mathematical description, a universal law that explained why an apple falls and the moon orbits the Earth. Then, a century ago, Albert Einstein revolutionized our perception entirely. He revealed that gravity isn't a mysterious force pulling us from a distance, but something far more profound. Gravity is the curvature of space-time itself. Massive objects literally warp the four-dimensional fabric of the universe, and other objects simply follow these curves, like marbles rolling in a bowl. This beautiful, mind-bending theory of general relativity has been tested and proven correct to an astonishing degree of accuracy. It predicts the bending of starlight, the wobble in Mercury's orbit, and even the existence of gravitational waves, ripples in space-time that we can now detect from Earth. So the case is closed, right? Gravity is a solved problem, a known quantity. But what if it isn't? What if this fundamental force, this cosmic bedrock, has a secret? What if, deep within the fabric of reality, there is a flaw, a bug in the universal operating system? Imagine a gravity glitch, a hidden variable, a forgotten force that can undermine everything we think we know. This isn't just wild speculation. For decades, astronomers and physicists have been staring at anomalies, at cosmic observations that stubbornly refuse to fit our perfect models. It's like listening to a beautiful symphony and hearing a single dissonant note that grows louder and louder the more you try to ignore it. The first major sign that something was amiss came from observing galaxies. When we look at a spiral galaxy, we see it spinning. Using our understanding of gravity and the visible matter we can see, the stars, gas, and dust, we can calculate how fast it should be spinning. But when we measure its actual rotation, we get a shock. The outer stars are moving far too quickly. The outer stars are moving far too quickly. Based on the visible matter, they should be flung off into the void of intergalactic space, like children flying off a merry-go-round that's spinning too fast. To solve this puzzle, scientists propose the existence of an invisible substance, something that doesn't emit light or energy, but has plenty of gravitational pull. They called it dark matter. It's a sort of cosmic glue, an unseen halo of mass holding these galaxies together. And it works, mathematically. But it's also a giant patch on our theory. We've never directly detected a single particle of it. It's a ghost that makes up an estimated 27% of the entire universe, yet it remains a complete enigma. This was the first major crack in the facade of our perfect understanding. It was the universe telling us, you don't have the full picture. But the mystery deepens. The dissonance grows louder. Einstein's own equations contained a hint of something strange, a term he called the cosmological constant. He initially added it to his theory to force the universe to be static and unchanging, which was the prevailing belief at the time. But when observations by Edwin Hubble showed the universe was, in fact, expanding, Einstein famously called the cosmological constant his biggest blunder and discarded it. He thought he had made a mistake, trying to hold back a dynamic cosmos. But what if it wasn't a blunder? What if it was his most prescient prediction? Decades later, in the late 1990s, astronomers studying distant supernovae made a discovery that shook the foundations of cosmology. They expected to find that the expansion of the universe, which began with the Big Bang, was slowing down due to the mutual gravitational pull of all the matter within it. It's a logical assumption. If you throw a ball in the air, gravity slows it down and eventually pulls it back. The universe should be no different. But they found the exact opposite. The expansion of the universe isn't slowing down, it's accelerating. Something is pushing everything apart. Something is actively working gravity on the largest scales. This mysterious anti-gravity effect, this forgotten force, was dusted off and given a new name: dark energy. And it's not some minor component. Based on our best measurements, it makes up a staggering 68% of the universe. The ordinary matter we know and love, the stuff that makes up you, me, the planets, and the stars, is less than 5% of everything. We are a cosmic afterthought, living in a universe dominated by two mysterious entities, dark matter and dark energy, whose true nature remains unknown. This is the stage for our investigation. We have a universe where the force of gravity, as we know it, fails to explain the rotation of galaxies and is being actively overpowered by an unknown repulsive force. This isn't just a small adjustment to our theories. This is a fundamental crisis in our understanding of reality, hinting that gravity might not be the constant, unwavering force we assumed. It suggests the possibility of a cosmic battle between forces, and perhaps in some places or under some conditions, gravity loses. What if there are regions or even eras where this forgotten force reigns supreme, making gravity almost non-existent?
Non-existent gravity, cosmic mystery. So, we stand at the edge of a cosmic mystery. The familiar force of gravity is being challenged by ghosts in the dark. But what are these ghosts? Where does this forgotten force come from? The leading suspect, as we've seen, is dark energy. But what dark energy? The terrifying answer is, we don't know. The simplest explanation is that it's an intrinsic property of space itself. It's the cost of having space, a baseline energy that exists even in a perfect vacuum. This is Einstein's cosmological constant resurrected. According to quantum field theory, a vacuum isn't empty at all. It's a roiling, bubbling sea of virtual particles popping in and out of existence. This vacuum energy would exert a negative pressure, essentially pushing space apart, behaving exactly like dark energy. It's a perfect match. There's just one tiny problem. When our best physicists try to calculate the theoretical amount of this vacuum energy, the number they get is catastrophically, comically wrong. It's 10 to the power of 120 times larger than what we observe. This is widely considered the worst theoretical prediction in the history of physics. It means our understanding of quantum mechanics and gravity is profoundly, fundamentally broken at their intersection. This catastrophic failure forces us to look at more exotic possibilities. Perhaps dark energy isn't a constant. Perhaps it's a dynamic field that changes over time and space, something called quintessence. If this is true, then the strength of this anti-gravity force isn't fixed. In the distant past, it might have been weaker, and in the far future, it could become overwhelmingly powerful. This leads to one of the most terrifying theoretical fates for our universe: the Big Rip. Imagine a future where the repulsive force of dark energy continues to grow stronger. First, it would overcome the gravity holding galaxy clusters together, sending individual galaxies flying apart. Then it would become strong enough to overcome the gravity holding individual galaxies together. Star systems would be torn asunder, and our own solar system would be dismantled. Planets would be stripped from the sun. Eventually, the force would be strong enough to overcome the gravity holding the Earth itself together, and our world would disintegrate. In the final moments, it would overcome the electromagnetic and nuclear forces holding atoms together. The very fabric of matter would be ripped apart, leaving a universe of isolated fundamental particles in an ever-expanding empty void. In this scenario, the gravity glitch isn't just a glitch, it's a doomsday switch. But the rabbit hole goes deeper. Other theories, born from the quest to unite gravity with quantum mechanics, offer even stranger possibilities. String theory, for instance, posits that the fundamental constituents of the universe aren't point-like particles, but tiny, vibrating one-dimensional strings. This theory requires the existence of extra-spatial dimensions beyond the three we experience. So where are they? The idea is that they are curled up, compactified, on a scale so unimaginably small we can't perceive them. In some of these models, gravity is unique among the forces. While forces like electromagnetism are confined to our three-dimensional brain or membrane of existence, gravity is free to leak out into these extra dimensions. This could explain why gravity seems so much weaker than the other fundamental forces. It's like shouting in a huge concert hall. Your voice spreads out and becomes weaker over distance. If gravity is diluted by spreading across extra dimensions, it could mean its influence isn't as straightforward as we think. Could fluctuations or changes in these hidden dimensions alter the strength of gravity and our own? Could a gravity glitch be a ripple from a higher dimensional reality? This leads us to the ultimate terrifying thought. What if a region of space could exist where gravity is, for all intents and purposes, switched off? If dark energy can overwhelm it, or if it can be diluted by extra dimensions, then the concept of near-zero gravity zones isn't pure fantasy. What would such a place look like? It would be a realm of pure chaos. Without gravity to act as the universe's great sculptor, nothing could form. There would be no stars, because gas clouds would never collapse to ignite nuclear fusion. There would be no planets, because dust and rock would never clump together. Any existing matter that drifted into this zone would simply disintegrate. A star would explode, not in a supernova, but by its own internal pressure, its constituent gases flying off in all directions, unbound. A planet would crumble, its own mass no longer sufficient to hold it in a sphere. It would be a cosmic dead zone, a place where the fundamental rule of cosmic construction has been repealed. We look out at the night sky and see order, structure, and beauty, all orchestrated by the reliable hand of gravity. But perhaps we are just living in a calm, protected bubble. The universe beyond could be far wilder, governed by a forgotten force that is slowly, inexorably winning the cosmic tug-of-war. The truth is, we are adrift in a cosmic ocean, and we've only just begun to understand the terrifying currents that lie beneath the surface. The glitch is real. It's in the spinning of the galaxies and the accelerating expansion of space itself, a constant reminder that the force we depend on for our very existence might just be a temporary state of affairs in a universe far stranger and more frightening than we ever dared to imagine.